Hey there. Let's see. I'm going to share my screen. Hey, can you hear me? Great. Oh. So you should be hearing me through VR now. Thanks for joining us. So we got Alloverse, which is quite special. It's interesting to see this collaborative 3D environment. So thank you to you guys. Thank you. All right, so we have an absolute overkill setup here to present from VR. So let's see. Yeah, that looks like it's working. So hi there. I am Nevin.
And I'm Tobias Kask.
We really appreciate being invited here to AECTECH to talk about our vision for the future of computer interfaces and to show you what we're building here at Alloverse. It's a really different system from what you might be used to, so we figured the best way to explain it is to show you.
So, what you're looking at right now is Alloverse running on a flat screen PC, being screen shared into the call, while Nevin here and I are inside Alloverse in VR, connected through our Oculus Quest 2 headsets. Just so you know, this setup means that we can't hear you, so please save any questions you may have until the end of the presentation. So first of all, what is Alloverse? Number one, it's a collaborative workspace, which means we can be multiple people in this place and talking and working together. Second, it's an open source app platform, which means that software specifically written for Alloverse can run as 3D objects in the same space as us. We call them apps. For example, this slideshow we're looking at right now is an app.
So I figure let's try it out a little bit more before we go deeper in what this all means. So this place is pretty empty right now. So I figured let's go to the marketplace here and pull out an environment. Let's grab the house here and put it here. And there we go. That's much cozier. Let's see, what else? We have a clock. So let's put a clock over here. Let's not have it in the wall. And that is 2 hours off, actually. So I want to just adjust that real quick.
Swedish time.
So that's our local time here in Sweden. And yeah, the slides and everything. So all the different aspects in here are different apps. And this is what it really makes this different from other platform is that these are all apps running on the internet and they're written in different languages and for different environments. And anyone can extend Alloverse with new functionality, which can be pulled into VR with us and used together with the other apps. So one really exciting such app relevant to your field is Emil Poulsen's Shape Diver Viewer app for Alloverse. And here's Emil to show you now.
Hey guys, this is Emil Poulsen from Core Studio speaking from Alloverse. So I was hoping to show a little experiment here that we've been doing together with the Alloverse peeps. So the concept here has really been try to bring Shape Diver actually into Alloverse to explore parametric design in a collaborative VR environment. So if you haven't heard about Shape Diver before, it's a platform basically for running Grasshopper definitions in the cloud. And they will also present on Monday if you're interested in hearing more about that. But so what we're looking at here behind me is a representation of a Grasshopper definition with a selection of parameters in a dashboard. And these parameters will generate a specific geometric output according to the underlying Grasshopper definition. So if I just turn around here and change some of those, let's see if we can mess around with the lower radius maybe to 0.7, then we should hopefully see something popping up here in the background. So I'm going to turn off the house now. It's better. And just to sort of show what it's doing a little bit more clearly here. But basically, when we manipulate the slider, there is a computation request being sent away to the shape direct backend, and back comes a GLTF asset that we can add to the Alloverse environment. So to summarize here, what I find really interesting with Alloverse from the perspective of AEC is that, well, first of all, that it's distributed. I mean, it's totally distributed in the sense that I'm actually running this shapediver backend on my own machine, on my laptop, basically. So, and then obviously like the C SDK that I think Nevin will show a little bit more later makes it really easy to get up to speed with. We actually just spent a couple of afternoons working on this. And then of course, like the collaborative nature of this, right? So since the app is plugged in here now, obviously Toby and Nevin can also interact with the sliders. So yeah, feel free to do that. And I think I'll just stop here and let Nevin and Toby talk more about the platform. But yeah, feel free to ask me any questions in the social channel later. Cheers, bye.
Cheers.
Thanks a lot, Emil. All right, so let me put the slides back. Oh, Toby's doing that. Awesome.
I'm doing that. Here we go.
Thank you. Is that rotated? There we go. All right, so I figure before we go deeper, let us give you some background on who we are and really why we're doing this. So Alloverse is a team of 6 people. I'm Nevin, and I've been an iOS developer for over a decade. I worked at Spotify for a few years, building large parts of their initial iPhone and iPad apps. And then I went on to found the UX research platform Lookback for another 7 years. So I really believe in direct manipulation as an interaction method with computers, but I've been a bit disillusioned with products such as the iPad as a workstation platform. It hasn't really worked out. I'm really disappointed in that platform. And so I'm fully on board with VR and AR as the future of computing. I believe that the move to spatial human-computer interaction is as inevitable as the move to smartphones and multi-touch was a few years ago. And as we build new platforms for new software, we have this chance now to correct some of the mistakes in the past decade of computing. For example, to go back and get back to the core values of the open web, which I'll talk more about later.
All right. And I'm Tobias, like I said. I've been working as a UX and UI designer and engineer my entire career, mainly for a US dating app, actually, but also on a variety of other products before and after, like a travel planner and a health tracking app. What I find somewhat unusual about my career is that outside of the 5 years I spent working in office in San Francisco and New York, almost my entire career has been spent working remote. So I've seen a bit of an evolution in this field. When I started working about 15 years ago, remote collaboration meant receiving an email from collaborators in the morning and sending an email back to them as the workday ended in the afternoon. Nowadays, remote work is surging, not just, but like obviously over the past year as well. Sophisticated collaboration tools like Zoom and Slack, Google Docs, Miro, etc. are being used daily. And this is a huge improvement, of course. But what's the next big thing? Surely our kids aren't going to be bending their necks and squinting their eyes at the phone and laptop screens of today, right? So like Nevin, I'm convinced that the move to 3D and spatial interfaces isn't just inevitable, it's also coming quite soon. So let's take a quick look at why I say that. First of all, there's a lot of money going into VR and XR right now. For example, did you know that that XR, R&D accounts for about 20% of Facebook's workforce right now? They're investing heavily in this, and not just Facebook. This is projected XR market size, for example, and we're just at the precipice of of something huge. Next, tech is rapidly getting cheaper and better. The headset I'm wearing right now has about twice as much performance, or twice performance as its predecessor. That was released 18 months earlier. And this new one sells for 3/4 of the price. So, yeah. As a result of these developments, sleek yet performant XR headsets are soon to hit the market. And at that point, I believe XR will truly begin its march into mainstream and start replacing the smartphone as the de facto computing platform. Finally, a bit of a softer argument that I'm putting in just because I've been working with UI my whole life. Interacting with things in 3D just makes sense for humans. For obvious reasons, we're living in 3D. Much of 2D interface are just metaphors based on 3D objects and interactions. And with direct access to an additional dimension when building UI, we can circumvent a lot of the learning required to understand it. VR is a great place to explore spatial computing and building the infrastructure for how we will use computers in the next 20 years. And with Alloverse, we're given the opportunity to invent a completely new way to interact with data and each other. With this comes new opportunities and future standards for communication and collaboration. And so what does Alloverse want with the future of remote collaboration? What do we want it to look like, Nevin?
Whoops, sorry. So with Alloverse, Alloverse is open source and it's distributed and federated. So those are some core values of the old open web that I really, really enjoyed, that we now want to take forward and translate that to spatial computing. We have open standards that anyone can interoperate with. We advocate self-publishing instead of being locked into commercial and walled gardens. And, anyone can build your own Alloverse app in any language and run it anywhere on the internet.
So how will we get there? First of all, these are the goals for Alloverse over the next few years. The next one is to work inside Alloverse, kind of what we're doing right now, using screen sharing, which is coming soon, and also other coder and designer companion tools. Next, we want to build a marketplace. You've seen something on the side there, which is not, it's a first neural version, of course, but the point of the marketplace is to also add subscription, payments, app hosting, etc. So that easy access to other people's apps. Then we want to work with domain experts like Emil and also like you guys. We want to build super useful apps in, for example, architecture and data visualization and much more. And eventually down the line here, the goal is for Alloverse to become an open and free standard for XR collaboration, preventing Facebook and Apple from owning a centralized walled garden ecosystems for app development. I believe that now is an awesome time to get started with VR. I'm convinced that we'll be looking back at these years as truly pioneering for human-computer interaction, and that to me is incredibly exciting. So, when enough talk, let's start writing some code. Nevin, take it away.
All right. So I'm going to jump out of VR and sit down on my laptop and switch the presentation. Hopefully that works. I'll be right back.
Take a seat. I'll stick around in VR for a little longer.
Let's see. Can y'all hear me? I'm going to, time's up. Nice. So, I'm going to share my screen, make sure I don't have any secrets on here. And there we go. So, let's build an app in Alloverse. So, where are my notes? I need my notes for this. So, our main app building language is Lua. but Alloverse is usable from pretty much any language. And we built UI libraries for some of our favorite languages. We've understood that AEC favors C Sharp. So we have a beta of a C Sharp library really premiering publicly today, which was used to build that ML's shape type reviewer. There is a guide on our website. So at docs.alloverse.com, you have a get started guide, one for Lua and one for C Sharp. And I'm going to do an abbreviated version of the C Sharp guide here with you. If you want to do it on your own, at your own pace, you're super welcome to do so. You should be able to do that on basically any computer. I'm a Linux nerd, so I'm going to use command line tools, but of course this is C Sharp. You can use Visual Studio and that works just as well. So let's see. Let's start out creating a new project here. So .NET new console. So it's a console app. Let's call it fancy app, and that exists. So let's remove my previous client, and there we are. Fancy app. And all we need is the Allo UI, which is our UI library for Alloverse. So .NET add package Allo UI. And there it is. Let's open that in Visual Studio Code and have a look. So I hope this text size is good for you. So there are 3 steps we need to do before this will work. I'm just going to do some imports. And let's see, we have the namespace and everything. So we need to set things up first. Here we go. So we need to set up an app that maintains the connection to the Alloverse place. So remember, Alloverse is running on a server on the internet, which all the users and apps are connecting to. So this maintains that connection for us. Then let's make a run method here, which basically creates our state and then creates some UI. So we need some UI to present, otherwise what uses our app. And then the third step is to connect to the Alloverse server we've defined here, and then just run forever, serving requests and interactions from users. So let's make some UI. I'm going to copy paste this so as to not mistype here in the demo, and then tell you what this code is doing. So writing UI in Alloverse should feel somewhat familiar. It's a tree of view objects. So if you're a web programmer, that's sort of like the DOM tree. If you're an iPhone or Android developer, that's sort of like a UI kit or fragment tree, like a view tree. And the difference really is that it's 3D. And now suddenly you have to deal with an extra dimension, an extra coordinate that you might not be used to, or most people might not be used to that third dimension, but I figure this crowd has an extra good grasp of that third dimension. So let's do something simple here. We're creating a cube that the rest of the UI can rest on top of. All UI components are created with a bounds object, which is the position and the size of the object. room. Hey, Toby. And then I am going to run this new fancy app of ours. So we do that with .NET run, and then the URL to the place. And demo gods, please work.
Ta-da.
Yeah, there is. So here's our app we just built. So I'm gonna click the button, it does things, and Toby can click the button, and anyone in the room can press the button. So notice what's happening here. Toby is somewhere else in the city, connected to this place, clicking this button, which is actually printing in my terminal on my computer, because he's interacting with an app on my computer. And I'm gonna let's just do a live change just to show you how easy it is to iterate with this thing. Let's make the cube twice as wide. So I'm gonna kill it, run it again. It's gonna compile my sources, and there it is, and it's double as wide, and Toby can see me do it. So you know, we can iterate on this thing interactively and in real time. So I think one of the most exciting things about Alloverse is that since apps are running anywhere on the internet, it means the app can run also on your servers, doing some really heavy lifting. Like it could be importing some really heavyweight AEC libraries, do complex calculations, and then visualize them to the user. And or it could talk to other servers in turn, like Emil's app did. But in neither case will the user's computer or headset be burdened by that computation, and this Alloverse lightweight visualizer can visualize really complex data. And I think before we end, I'm just going to make sure that we have this slide up to tell you that you can go to alloverse.com and check it out, see, read the docs, get started on your own, and you can join our Discord to come chat with us about whatever, and get help in writing your own apps, or just ask questions if you're curious, or just tell us this is silly, or whatever you want. We'd love your feedback. So come talk to us. And that's really all we have for you today. So if you want to talk more, we would love for you to either come to our Discord or come to the social room here in Spatial, and we can go chat. So that's all from us. Thanks very much.
Right. Thank you.
Wonderful. Thank you very much. That's, yeah. As I said before, it's mind-blowing. Like I said. I really like the collaborative aspect, and that it's so light to actually run for the user. I think this is pretty awesome.